All right, so today's lesson is going to be on limiting reactants. Up to this point, we've been making the assumption that during a reaction, all of the reactants get used up and I have no reactant left at the end. The reality is that is not always the case. So a limiting reactant is going to be a way for us to determine how much reactant is left over, if any. And we're going to look at limiting reactants in terms of a particle diagram. So let's say I have 6 moles of solid magnesium and 6 moles of oxygen gas, and they react to form magnesium oxide. All right. Let us balance our equation. There we go. Now let's draw us a particle diagram. If I have 6 moles of magnesium, I'm going to draw magnesium, just a circle with a line through it. And I have oxygen gas, and we know that oxygen gas is diatomic when by itself. So I have 6 of these. All right, what is going to happen? I am making magnesium oxide. So let's draw our reaction after. 1 magnesium and 1 oxygen. So 1 magnesium and 1 oxygen. 1 magnesium and 1 oxygen. 1 magnesium and 1 oxygen. Magnesium and oxygen. Magnesium and an oxygen. And a magnesium and an oxygen. All right, at this point, my magnesium is all used up. Notice I put an X around each one that I used. I have no more magnesium left, so my reaction cannot keep going. I have 3 oxygens left over. Now, this is what I have after. 1, 2, 3, 4, 5, 6 magnesium oxides and 1, 2, 3 oxygens. Now the reality is this is a mixture, okay? So these oxygens and magnesium oxides are all mixed up together. They are not clumped with all of our magnesium oxide on one side and all of our oxygen on the other side. All right, so in the real world, these are all mixed together. They are not clumped, but I have them clumped for good visual purposes. All right, so how many moles of magnesium oxide are produced? 1, 2, 3, 4, 5, 6. Which reactant is in excess? That is going to be the oxygen because I have oxygen left over. So we call that, say that it is an excess. How many moles of excess reactant are there when the reaction comes to completion? 1, 2, 3. So what is my limiting reactant? My limiting reactant is what gets used up. My excess is what is left over. Now let's take our particle diagram and let's look at it in terms of a Rebecca chart. All right, so I have 6 magnesiums and 6 oxygens. And we saw up here that the magnesium gets used up first. So this is where I'm going to start because the magnesium is what gets used up. So 2 over 2 times 6. All right, and we are using it up, so that's a minus. So that is going to become a 0. Now, how many moles of magnesium oxide are produced? So I'm going to come over here. I have no magnesium oxide to begin with, right? When we first started, this had nothing in it. We had to draw it in. So I have 2 moles of magnesium oxide for every 2 moles of magnesium times my change of 6. And so 0 plus 6 is 6. So I have 6 moles of magnesium oxide. Which reactant was in excess? So let's look here. Let's look at the oxygen. I have 1 mole of oxygen for every 2 moles of magnesium times my change. 1/2 times 6 is 3. 6 minus 3 is 3. So my oxygen was in excess because I had some left over, and we had 3 moles left. So let's look at our follow-up questions. And let us compare. We're going to look at our A's, our B's, and our C's. So when I drew my particle diagram versus my Rebecca chart, we notice the values are the same. All right, let's look at part B. Which one is in excess? So my B said oxygen, and then my B for my Rebecca chart was oxygen. So again, those are the same. Let's look at C. C for my Rebecca chart gave me 3, and C for my particle diagram gave me 3. So again, those are the same. So what is magnesium representing? Because magnesium gets used up, it is representing what we call the limiting reagent, which is also called a reactant, limiting reactant. So you may see the word reagent, you may see the word reactant. I typically use the word reactant, just because that's how I learned it. So let's try number 2. I have 8 moles of nitrogen. Nitrogen is diatomic. All right, so I've drawn in my 8 nitrogens, and I have 12 moles of fluorine gas. So I'm going to draw in 12, and look, fluorine is diatomic, so I'm going to draw in 12 here. All righty. Now, this is my before. This is what I start with. Notice I have no product to begin with because we haven't made any. Let's start making our NF3. I have 1 nitrogen and 3 fluorines. So a nitrogen and 3 fluorines. A nitrogen and 1, 2, 3. Nitrogen and 3 fluorines. A nitrogen and 1, 2, 3 fluorines. And we're just going to keep going. 1 nitrogen for 3 fluorines. And 1 nitrogen for 3 fluorines. And 1 nitrogen for 3 fluorines. And 1 nitrogen for 3 fluorines. All right, and at this point my reaction stops because I have no more fluorine. I have used up all the fluorine. So how many moles of nitrogen trifluoride are produced? 1, 2, 3, 4, 5, 6, 7, 8. Which excess or reactant was in excess? My nitrogen is in excess. I have 1, 2, 3, 4 nitrogens. So I'm going to put those in here. And I'm going to go ahead and kind of mix these up a little bit here to show you a better particle representation of what it may look like. Okay, our 4 nitrogens are mixed up. This is a mixture. They are not clumped together. They are in fact mixed up. So my nitrogen is in excess, and I found that I had 4 of those left over. So let's do our Rebecca chart. We must balance our reaction. Now, we saw that fluorine got used up first. So I had 8 nitrogen and 12 fluorine, but fluorine got used up first. So this is where I'm going to start with my fluorine. 3 over 3, and it is a used up. It is a reactant. It is being used up, so that is a minus. So 12 minus 12 is 0. I had no fluorine left. How much nitrogen trifluoride is produced? All right, so I have none to begin with. A 2 over 3, and this is an addition, times 12. Now, if this Rebecca chart is confusing you, you need to go look at my Rebecca chart video to help you learn how we solve this. All right, so 0 plus 2/3 times 12 is 8. So we had 8. Which reactant is in excess? Let's check out our nitrogen. I have 1 over 3 times my 12. So 1/3 times 12 is 4. 8 minus 4 is 4. So I do have nitrogen left over. It is in excess. And how much? 4 moles. So let's look again and let's compare our same follow-up questions. A in our particle diagram versus our Rebecca chart are both 8. Nitrogen is the excess regardless of whether we do a particle diagram or a Rebecca chart. And we had the same amount of nitrogen left over in each. All right, so we had the same answer for all 3, A, B, and C. What does fluorine gas represent? So fluorine gas got used up, so that is our limiting reactant. Now, particle diagrams are a great way to introduce this, and I really love to introduce with a particle diagram, but these are tricky in terms of the amount of time. So what if we had another way to do these that was actually less time than drawing out a particle diagram? So this is where number 3 is going to come in. All right, step 1. When we read our problem, step 1, we need to write us a balanced chemical equation. So I have copper and silver nitrate, and they are going to react by a single replacement. Hint, copper is going to form a copper 2 ion. Okay, so copper is going to create copper 2 nitrate, and the only way for you to know that is for me to tell you. There is actually, in fact, a way, but that is beyond the scope of our course. So I'm not going to expect you to know that and how to figure that out. That's something that we'll investigate a little bit more if you take AP. Okay, silver is left by itself. So here we go. Now we got to balance this reaction. There we go. All right, now let's identify the limiting reactant. So step 1. These are in moles, so that's good. If they were in grams, I would have to convert to mole. But since I was given the mole, step 1, I am going to write in my before values. These numbers come in here. Now, this is where students get tricked up. Sometimes students use the wrong value right here in our limiting reactant, and let me show you what I mean. To determine the limiting reactant, copper has 2.5 moles of copper. All right. And a silver nitrate has 5.5 moles. Now, for every 1 mole of copper, 2 moles of silver nitrate is used. So silver nitrate is being used up twice as quickly as copper. We are going to take the value from the before and divide it by the mole from the balanced equation. There is an understood 1 in front of the copper. So 2.5 divided by 1 is 2.5. I'm going to take my 5.5 and divide it by the 2 from the silver nitrate, which is going to give me 2.75. These values are the values used to determine the limiting reactant. 2.5 is smaller than 2.75. So what is my limiting reactant? Copper. All right. Copper is my limiting reactant. Now, students often will pull these values from their limiting reactant determination and put them in the before. That is not what you use. You use the values provided to you in the before. Now, how many grams of silver are produced? So I'm being asked to come over here to the silver. Copper is my limiting reactant. This is the one that gets used up. This is the one that is at a 0. This is where I start. So I have 1 over 1 times 2.5, and then we're using it up to give me 0. My silver is a 2 over 1. We're making product times my change, which is 2.5. So 2 divided by 1 times 2.5 is 5. So how many grams? I have 5 moles. So be careful, we're asked for grams. So I'm going to have to take my mole and go from 1 mole equals the mass from the periodic table. I'm going to have to do a simple conversion there. So I'm going to make 539 grams of silver. All right. Now you'll notice in my Rebecca chart, I did not worry about the copper 2 nitrate because I was not asked about it. So when solving a Rebecca chart, you can do the entire problem. You could go anywhere from anywhere, but don't waste your time doing something you're not asked about. I wasn't asked about how much silver nitrate was left. I wasn't asked about the production of copper 2 nitrate. So I'm not going to waste my time doing something that I am not asked to do.